At Diamond Plastics, we have assembly guides for all of the products that we produce to give guidance for the contractors and how they put the pipe together in the field. There are things that need to be done, stop at the assembly marks, straight assembly, and the projects will go as planned without leaks and without rework. In the factory, we put a bevel on the end of all of our spigots of pipe. That bevel has a taper on it, and the smallest diameter of that bevel will fit inside the gasket for straight alignment. That can be seen in our example piece here. You notice that at straight alignment, the gasket has already started up the wall of the bevel for easy straight assembly. If you misalign the spigot into the bell, the gasket is going to catch on the end of the spigot and assembly forces will be a lot higher, and there's chances of pulling the gasket loose, damaging the gasket, and therefore having a leak. But at straight alignment, everything works very well. Similar to our small diameter product that I just showed you, the bevels on our larger products, like this 16-inch, has a similar bevel at 15 degrees with a 45 at the end and an 1.5 inch length, so that the gasket sealing bulb during straight alignment will hit on that bevel. Our 36-inch pipe, this taper becomes 2 inches in length so that the gasket will hit right here. On our 54 and 60-inch products, this bevel becomes 3 inches in length so that the gasket will hit at the start of the bevel for easy assembly. And the assembly guides refer to the contractor for field cuts making a bevel as close as possible to these shapes and sizes for easy assembly. The assembly guide says that you lube the bevel of the spigot and the gasket prior to assembly. An important thing to note with this lube is it tends to attract any kind of foreign material. So if the brush, the glove, whatever you're using to apply the lube gets dropped in the dirt and bedding, do not contaminate the remainder of your lube bucket, or every joint that you make from that point on has the potential for foreign material in it that may cause a leak. Okay, so we will lube the gasket on the sealing bulb and a little bit up front. In addition, we will lube the spigot along the bevel that needs the lubrication. Get it placed into the lip of the bell without attracting any dirt, bedding, or other foreign materials. And assembly is made very easy. You stop at the first mark and you can see that the deflection for 1 degree does not stress the bell. You can see that the deflection rotates along the gasket, and there is no stress that will shorten the life of the product. Assembly to the second mark gives the same allowed 1 degree of deflection without stressing the bell. Any over deflection again stresses the bell. Assembly clear to the back, which is often referred to as homed, adds stress to the bell, moves the rotation for any deflection to the back of the bell that compresses a gasket and decompresses the other side, which can cause a leak. So any rotation whatsoever causes additional stress on the bell, which will shorten the life of the product. As we have just shown with our demonstration of assembly here in a lab, the minimum and maximum insertion of the spigot into the bell is critical for the 1 degree movement that is allowed. Similar to a dipstick on an engine, there is a minimum and maximum oil level, and if that is not at minimum or exceeds the maximum, voids the warranty on the engine. If we are not at minimum or exceed the maximum on our assembly of the spigot into the bell, it voids the warranty on the product and shortens the life. For 4 to 12-inch pipe for assembly in the field that is not a laboratory condition, there are manufacturers of tools similar to this one. I believe Reed and Eagle Claw are a couple examples, and you can assemble the pipe identically to how we have in our laboratory condition here, stopping exactly between the marks. If you are dealing with very large diameter pipes, such as 54 or 60-inch, tools are not available. But many contractors have had success in positioning the bucket of the backhoe against a pad that is against the bell of the pipe being inserted into a previously installed pipe. The bell of the installed pipe must be restrained so that it doesn't move because of the assembly forces. That has been successfully done by cabling it back to trench boxes, by positioning another piece of equipment over the top of the pipe, or attaching it with a sling or a cable to another piece of equipment to hold it in place. And then once the bucket is placed against the pad, the machine should be walked into position, not pushed with the hydraulics of the arm, because the assembly force is reduced to approximately 1/10 once the bevel on the spigot is past the sealing bulb of the gasket, and you cannot stop soon enough with the hydraulics due to the stored energy in the system. But by walking the machine, you can stop exactly where you want to in a very controlled manner. We have shown you why assembly according to the assembly instructions is important. It helps to reduce assembly forces. It helps to increase your productivity because it's easier to do. And it also helps to ensure that the product will last 100+ years as it's designed. Similar products such as POP say, don't shake prior to opening, and we all know what kind of a mess that can be. So please do not over-assemble the joints, do not over-deflect the joints, and have straight assembly so that you don't have a mess in the future.